Okay, so I'm going to do a video showing you how to do problem 12A, 12B, and 12C from a Cal 2 exam we just had. It was our midterm. And let's continue. So 12A, the question says, given fx equals x minus 2 and g of x equals negative x minus 4 squared plus 4, make a sketch of these curves and find the area between them. Alright, so as you can see, I wrote the equations out, did the sketch. G's on top, f of x is on the bottom. Points of intersection are 2 to 0, 5 to 3. So we're going to plug all this information into our equation right here. So top is top function, which is g of x, and the bot is f of x. A and b are x values, so it's going to be 2 and 5. Let's continue. So I wrote, like I said, wrote g, wrote f, g, f, and then I put our points 5, 2. So then I expanded them and distributed the negatives. So this is what g is, it looks like expanded, and this is me distributing. So then we simplify it. Then I took the integral, or the definite integral. Then I found the integral antiderivative. That's what I did. Then I put 5, 2. Then we do the second fundamental theorem of calculus. So I plugged in the 5 here, 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 and here. And then I subtracted it with the equation plugging in the 2. See? Then I plugged all in, then I distribute, and then I found all the math basically. And it equals 4.5. This is 12A. So now let's continue to 12B. 12B. 12B says, here, I set it up for you. 12B says, following part A above, find the volume of the area generated by rotating the figure in part A about the line y equals 0. So during the test, you said don't apply the second fundamental theorem of calculus, but you must find the antiderivative. So let us continue. So from the first equation, we had to use the graph. I did a very, very rough sketch of this. Then I found the same curve, but below it. Then I made our washer. I blew up the washer into 2 pictures to help us figure out what r and little r and big R is. So little r is from here to here. So, and that is the function of f of x, which is x minus 2. Big R is from here to all the way up here. And that is our g, which is here. So then I squared them. That's what it looks like squared. And then I had to switch to pen because if I wrote marker, it would just take pages and pages, but bear with me. So this is what I did so far. Then next I expanded it. Then I multiplied each side to help me figure out what it is. Then I did a lot of math. Then here's some sloppy math, some algebra. As you can see, that is what big R squared looks like right here. Then we know our area is pi big R squared minus little r squared. So I squared them already. So I just have to subtract little r. So I distribute the negative to all of them and subtract it to big R, as you can see here. So this is what our area is going to look like. This is big R squared minus little r squared pi. So then now, since we all have that, we can finally plug it into our volume equation. So from B and A are still the same variables as last time, which is from 2 to 5. Then I put the pi outside because it's a constant. Then I put big R squared minus little r squared right here. Then I anti-differentiate. I got this 5 to 2, pi on the outside. And that's where we stop. That is 12b. Now we shall continue to 12c. Now 12c says, I'll zoom out for you to see it, what all my work looks like, or all the work I did. So 12c says, following part A and B above, find the integral equation that would give the volume of the solid generated by rotating the figure in part A about line equals -2. Alright, let us continue. So, just like the first problem, part B, I drew a picture. The original then had to rotate it on -2, so we had to go down 2 here. That's where it's going to be rotated. So, I had to go another down 2 to draw the similar picture. Did our little slice, found the washer, then I found our r, which is x minus 2. Then I had to put plus 2 because of the gap. So I solved r. Then I squared it to help us later on. Next, I found what r is, big R. So it's going to be, again, here to here. So I put that. Then I had to put a plus 2 because of this gap we have here. So I did that. Found r. Then I squared it once again to help us figure it out later on, make it simple for us. So this is r squared, big R squared. Then I subtracted a little r, and this is big R minus little r squared. So then we just have to put a pi to make it ax. So then I plugged it back into the volume here. We already know b to a, it's still 2 to 5, so we put 2 to 5. I put the pi on the outside since it's constant. Plugged it, and then I put it in the big R squared minus little r squared right here. And I differentiate it. And that's where we stop. And thank you for watching, listening, and thank you for letting us have this extra credit opportunity. Thank you.